Alright, and welcome to Solving with Factoring by Grouping. Now, we learned how to use factoring by grouping in our last lesson, and if you will recall, you always start when we look here, okay, our A term, we see here A is not equal to 1. And what do? Well, we test out our A term and our C term by multiplying them together. So when I do A times C, I know negative 6 times negative 3 is actually positive 18. Okay, so I multiplied A times C, I got positive 18. Now, if you'll recall, we're looking to break down 18 into all of its factors so that they add up to our B term, which is plus 11. So I have 1 and 18, which adds up to 19. That's wrong. I've got, I've got 3 and 6. 3 times 6 is 18, but 3 plus 6 is 9. What about 2 and 9? Well, 2 plus 9 is 11, and those are the two numbers that we were looking for. So when I start factoring by grouping, I'll bring it down to f of x is equal to negative 6x squared. I'll leave my minus 3 at the very end. And we're going to split this 11x essentially up into, you know what, let's put the 2x right here, the 2x with the 6, because 6 and 2 can both be divided by 2. And let's put the 9x with the minus 3, because 3 and 9 can both be divided by 3. So this is the first example of where the order actually does matter. Now you'll recall, we now put both of these, we put it into two groups, and we're going to factor out each group. So, hence the term factoring by groups. Okay, here I asked myself, what can negative 6 and 2 be both divided by? And I know that negative 6, we want to pull out the negative, and 6 and 2 can be divided by 2. Also, I see that there are two x's here, one x there. They can both give up an x. And what is negative 6x squared divided by 2x? Well, divided by negative 2x. That's going to be positive 3x. What is positive 2x divided by negative 2x? Well, that'll be negative 1. Okay, so here, let's use a different color for my next term. We have 9x and negative 3. Since the 9 is positive, we're just going to pull out a positive 3, and 9x divided by 3 is 3x, and negative 3 divided by 3 is negative 1. Now you'll notice here we have a 3x minus 1 and a 3x minus 1, and remember, that's the trick for knowing that you did this correctly. We'll say, you know what, we're going to pull this negative, or this 3x minus 1 out of both of these. So this factors into 3x minus 1, and when we take it away from here, we're left over with negative 2x, and we take it away from here, plus 3. Now that's factoring by grouping. That's what we did in our very last lesson. I want you to pause the video, finish taking your notes, and let me clean this up to finish up how to solve with factoring by grouping. Okay, now if you'll recall, to solve any quadratic, we always set it equal to 0. And so our goal becomes, we actually want to find a value of x that makes both of these factors equal to 0. And the way we really do that, and I never write it out so crystal clear here, but we actually take each factor and we're really setting each of them equal to 0. So I can type in 3x minus 1 is equal to 0. I can take this right factor, and I can write negative 2x plus 3 is equal to 0. And this will solve me for both of my x values. Okay, so we can add 1, and we'll get 3x is equal to 1. And of course, we divide both sides by 3, and we get over here, x is equal to 1/3, comma. Now let's go ahead and find our other solution. Here we have negative 2x plus 3, so minus 3, that zeroes out. Now I have negative 2x equals negative 3. And of course, to get the x by itself, we divide both sides by negative 2. And here, a negative divided by a negative is a positive, so x is equal to 3/2. Now, what is this really telling us? It's really telling us if we wanted to graph this, here's the value of 1, and here's the value of 2. Well, our very first 1/3 is crossing right here, and our 3 over 2 is crossing right here. And you'll notice this is just also has a negative a term. We have a very, very skinny quadratic that will look something like that. Now notice we don't know where the vertex is because we haven't solved for the vertex. So this acts as just kind of a rough quadratic graph. Okay, here we have example 2, and we have g of x is equal to 20x squared minus 7x minus 3. Now remember, to test for factoring by grouping, we'll take our a term and our c term, and we will multiply those together. We know that a times c, or 20 times negative 3, is negative 60. Now notice this is the special case where we actually have a negative number, which means that we're looking for two factors that will technically subtract to give us our b term. So let's talk about all the groups that we can think of. There's 1 and 60. Well, 60 minus 1 is 59. That's not what we're looking for. There's 2 and 30. 30 minus 2 is 28. That's not what we're looking for. There's 3 and 10. Oh, I'm sorry. There's 3 and 20. And 20 minus 3 will give us 17. That's not what we're looking for. There's 4 and 15. 15 minus 4 is 11. That's not what we're looking for. And then there is 5 and 12. Now 12 minus 5 is actually 7. Remember, we're looking for a b term of negative 7. That means our larger number has to be negative. So these were actually the numbers we were looking for, 5 and negative 12. Okay, so we'll take our g of x equals 20x squared. We'll leave a space for that minus 3. And now we want to split negative 7x up into 5 and negative 12. Notice 5 only has factors in common with 20, and negative 12 has factors in common with 3. So we always want to put these middle terms next to the factors that we can take out. Now I have struggled to find a coherent way to pull out numbers here. So here's what I'm thinking. I'm going to put this in purple, and I'm going to put this in orange, and I'm going to factor out the greatest common factor. Both 20 and 5 can be divided by 5, and x squared and x can both be divided by x. So I'm going to divide both of these by 5x. And then I'm going to put the remainder in blue. 20x squared divided by 5x will of course give us 4x, and 5x divided by 5x will give us plus 1. Okay, and over here in orange, because our 12, our leading coefficient, is negative, remember we're going to have to factor out a negative, and 12 and 3 can both be divided by 3, and we can't take out anything else. So in this orange, I'm going to factor out this minus 3 parentheses, and in blue, our original color, we know that negative 12x divided by negative 3x is a positive 4x, and negative 3 divided by negative 3 is a positive 1. Okay, and hopefully this seems a little bit more coherent on our colors, because now when we go to write this, where we have our common factor that we are going to pull out, when we write 4x plus 1, I can now show you the leftovers in their correct color. So our leftover here is 5x, and our leftover here is this negative 3. Okay, perfect. Now remember, to solve any one of these, you're always going to be setting it equal to 0. So we have 0 is equal to 4x plus 1 times 5x minus 3. And then all we have to do is set both of those equal to 0 to solve for x. So we can write 0 is equal to 4x plus 1, and 0 is equal to 5x minus 3. Now I'm going to pause the video, clean this up, leave myself a little bit of room, and I want you to finish taking your notes before you move on. Okay, now that we've set each factor equal to 0, well, we can simply solve for x. Minus 1, we have negative 1 is equal to 4x. Of course, I divide both sides by 4, and we get x is equal to negative 1 over 4. Here, I know I'll add 3 to both sides. Guys, this is basic algebra. If you struggle with this part, you're definitely going to need some tutoring. We'll divide both sides by 5, and x is equal to positive 3/5. Now, what is this going to look like as a rough quadratic? Remember, a negative value is going over here to the left, and remember it's 1/4, so it's not really going that far. And then our positive value, 3/5, is still less than positive 1, so it's somewhere right there. Now, it's a little bit further to the right. So when we go to graph this, our a term is positive. We know that our quadratic is going to open up, and our vertex will be shifted just a little bit to the right of the y-axis. Now recall, here, I don't know what the vertex is, so this is just a rough graph sketch of the quadratic. Alright, y'all, I'll see y'all in the next video.